So in this section, like I said before, we're going to put together sections 4, 5, 6, and 7. And the big idea is, if you're given some random polynomial like x to the 5 plus 5x cubed minus 7x squared, whatever, you're going to be able to solve it, no problem. Okay, until now we couldn't do that. We had to like factor and whatever, or graph and so on. Okay, so first thing we're going to do is, now we know that if you have a polynomial, and let's say the degree of the polynomial is 5, how many zeros does that have? 5. Now, how do you find the zeros, right? So this is the big idea then. How do you find those zeros? Okay, you don't have access to a graphing calculator. How do you find the zeros? Well, one way is, how many numbers are there in the universe? Infinite. So one thing you can do is, you can take every single number in the universe, plug it into the function, and see if it's going to give you 0 in the end. Okay? That's just silly. Okay, we're not going to do that. We have a way, okay, to get a much shorter list from an infinite number of numbers, narrow it down to a short list and say, okay, if this number has any real zeros, it's got to be one of these 8 or 10. 8 or 10 possibilities is still better than an infinite number of possibilities. So that's what we're going to do. So if you're given a polynomial function and none of its roots, right, it's a tedious task to check every single possible root. But the rational zero theorem, that's what we're going to be using, limits the guessing by revealing the possible rational roots. So if a polynomial has a rational root, what's an example of a rational number? 2. What else? How about 5 over 2? Negative 5. So if it has a rational root like those, then we could, with this rational root theorem, get a narrowed down list. Okay? All right. So here's how we do it. Basically what we're going to do is we're going to find this thing called P over Q. All right? How do we get P and how do we get Q? Well, if you have a function like this, f of x, right? You've got the leading term, that's the term with the highest exponent, and then at the very end, you've got a constant, right? The factors of this constant give you P. The factors of the leading term give you Q. Okay? It sounds more complicated than it is. If we just do a couple, you'll see what I'm talking about. So here it says, list all of the possible rational roots. And we're not going to solve. We're just going to list all of the roots. So here's what we do. From this number, we get P, right? So we want the factors of 24. All right. What are the factors of 24? 2 and 12. How about, is 1 a factor? Okay, so what I do is I go down the list. So 1 and 24. So 1 is a factor. 2 is a factor. I just keep going up. Is 3? 4? Okay, so once you get to like, okay, so 4, and then what else? How about 6? Yeah? So, okay, once you get here, like 6 times 4, right? Then, okay, you go to the 3. Yeah, so then what's the 3 times 8, and then 2 times 12, and then 1 and 24? Question. 1 times 24 gives you 24. How about negative 1 times negative 24? Yeah, that too, huh? So not only 1, but negative 1 is also a factor. So this is plus or minus 1, plus or minus 2. All of these are plus or minus. Okay, Q then is, you look at the coefficient here in front of the leading term. What's the coefficient? 1. From that number, you get your values of Q. So the factors of 1 are plus or minus 1. That's your Q. Now, you're not done yet. Now what we're going to do is P over Q. What P over Q is you're going to divide every single number up here with every single number down here, right? So you're going to do plus or minus 1 over 1, plus or minus 2 over 1, and so on, right? So then you're going to do plus or minus 3 over 1, you just get 3. 4 over 1, you get 4. 6 over 1, 8 over 1, 12, and 24. Okay? Now, it's kind of tedious to keep writing the plus or minus, so I'll let you do this. P over Q is equal to plus or minus, and then in parentheses, just put those numbers. Okay? How many numbers are on this list? 8, and then the minus versions of those, the negative versions, so 16. All right? So what we've done is, remember, okay, so this function, how many zeros does it have? 3, right? 3 zeros here because it's x cubed. Remember how we said you could try every single number in the universe and see if it's a 0? Well, now we narrowed it down. So if there is a if this has a rational number as a 0, it's got to be off of this list. So for example, x equals 5 is not on this list. It cannot be a 0 of this. You see what it is? You see what I mean? Like x equals 13 can't be a 0 of this. Negative 5 can't be a 0 of this. All right? Okay, let's do one more there. All right. So for P, what number are we going to look at? 10. So the factors of 10, I do plus or minus 1 time, and it'll be 1, 2, 5, and 10. Right? Any others? No. Yes.
I have a question. This may sound silly, but you know when you said all the numbers in the P have to be plus or minus? What if when you're multiplying, what if let's say you plug in one's negative 2 times positive 12?
Right. So you wouldn't. Right. So you wouldn't do that. You would also not choose, let's say, 1 and 5. Right. You have to choose the correct ones, but you're just listing all of the possible ones here. Okay. Q, we look at 3, and the factors are plus or minus 1 and 3. So, well, what are the factors of 3? How do you get 3? 1 times 3. P over Q then, it's going to be plus or minus. Now, I'm going to take each of those P's and divide it by each of the Q's. So first, I'm going to divide everything by 1. So I get 1 over 1, 2 over 1, 5 over 1, 10 over 1. Okay? Then I'm going to divide each of those P's by 3. So 1/3, 2/3, 5/3, 10/3. Okay? Yes.
What do you do when you get into really big numbers?
You write them.
So if you have 5 times,
Yeah. Yeah.
so for the reason divided everything by 1.
Everything on this list, you have to divide by everything on this list. So 1 over 1, 2 over 1, 5 over 1, 10 over 1.
Okay.
Then you do 1 over 3, 2 over 3, 5 over 3. Okay? All right. All right, rational 0. Okay, so now I know that if this had a rational 0, it's going to be off of this list. How many numbers here? 4, 8, 16 again. Now, how do you find them? How do you actually find them? We're going to test every single one we said, right? So essentially, that's how we start. So here's how you find them. Step 1. use what we just did to identify all possible rational zeros. That's what we just did up there. Step 2, you're going to test the numbers to find which are zeros. All right, we're going to do synthetic division. How do you know when you do synthetic division that you've located a zero? Exactly, when the remainder is 0. After finding the 0, after finding 1 0, we're going to do what we did in 5.6 and use it to factor the polynomial. Okay? So we're going to put everything we learned into use here. So one problem is going to rely on stuff we learned in like 3 different lessons. Okay, so first, we have to find all of the zeros of this function. First, we're going to use Descartes' rule to identify the possible patterns. All right? So let's use Descartes' rule here. Okay. How many times does this switch sign here? Once, twice. So for positive ones, it's 2 or 0. Then let's look at f of negative x. Can somebody tell me what f of negative x will be? Negative x cubed. Right. So how many times does this change? Once. Right? So number negative, 1. Okay. Positive, negative, imaginary. Okay? Positive, negative, imaginary. All right. It's going to be 2 and 1. Or 0 and 1. Okay? How many imaginary here?
0.
And 2. What does this tell us? This tells us that this function only has one negative 0. Okay? And then it could have either 2 positives or no positives. So let's identify the possible rational zeros. So let's do P. For P, I'm going to take the factors of 42, plus or minus 1, 2. I know you guys know how to do this. Is 4 a factor of 42? No. 6 is though, right? 7. What else? 3 times what is 42? 14, good. And then 2 times what is 42? 24, and then 42. Ah, 21 and 42, sorry. And then Q is plus or minus 1. So P over Q is just the same thing as we got for P. Okay? All right. Now, we're going to use synthetic division to find our real root. So basically what we're going to do, we have all of these numbers here, 1, 2, 3, 6, 7, 14, 21, 42, and they're negatives. We're going to use, so we have 1, negative 1, 2, negative 2, 3, negative 3. We're going to start doing synthetic division with each and every one of those numbers until we hit one that gives us a 0. Okay? And there is a little bit of luck involved here. It could be that the first one works. It could be that like the 14th one works. Okay? So students ask me, do I have to go in order or can I just do it randomly? Honestly, you have the same amount of chance either way. Right? It's the same probability either way. Okay? Yeah. Because this has a coefficient of 1. Okay. Yeah. What we have to help us though is Descartes' rule. It tells us there are only 2 positive numbers, right, that can be solutions, and only 1 negative number can be a solution. So once you find a negative number, let's say, you don't keep, you know that the other two have to be positive. You see what I mean? Okay. So let's start. Okay, so let's start with the 1. Let's start with 1 and do synthetic division here. Let's, what do you call it? Conserve some of your space here so you don't run out. Okay, so here we're going to put the coefficients of f of x. Exponents 3, 2, 1, 0 are all there, so we're good to go. 1, -6, -13, 42. Go ahead and do this. All right, so we get 1. All right, so here, you know, oh, it's done. So here, you know that you're not going to get a 0, just leave it. Okay, you don't have to find the remainder. You see what I mean? So, okay, so 1 didn't work. So now, here's the choice. Do you go to -1 or do you go to 2? Okay, let's go to 2. Leah says to go to 2. Let's go to 2. 1, -6, -13, 42. You really have the same chance either way. So 1, 2, -4, -8. And then what? And then -42. Oh my God, that actually works.
Yeah, I did it.
Like how cool. Oh, nice. I like that. I like that educated guess. Okay. So that one actually works. So you know what? Like that just saved us. Okay. So once you find one, you can use what we did in section 5.6 here and find the other stuff, right? Like we do the depressed polynomial and yada, yada, yada. So let's do that. So now it says, examine the depressed polynomial and find the remaining roots. I'm not going to walk you through it like this every time. It'll just be like one big step. So here, from here, I get x minus 2. And here, the depressed polynomial is x squared minus 4x minus 21 equal to 0. Now, can that be factored? Yes, it can be factored. So x minus 2, x minus 7, x plus 3 equal to 0. Finally, x equals 2, 7, and -3. As promised, did Descartes' rule predict that we would get 2 positive and 1 negative solution? Yes, it did. Okay, how awesome is Descartes? Seriously, though, right? Okay, so right, so it's a possibility. You either get that configuration or that configuration. So you either get 2 positive, 1 negative, or 2 imaginary and 1 negative. Okay, so we got the 1 negative, and then we ended up with 2 positives. Yes?
In the back of the book, when it gave answers, it did like a complete row. It said 2 positives, 1 negative, and 0 imaginary. Then went to the next and said, what is that? When we answered, do you want us to separate the 2 quote unquote?
It'll be clear on a test or quiz because I'll have like answer spaces and stuff provided for you guys. Okay? All right, so let's do this guy. This one's a little bit more complicated because you now have an x to the 4. Okay? All right. So let's start with Descartes. So number of positive ones. Let's see. There is a switch there and a switch there. Oh, no, and a switch here. Did I do that correctly? So 3 or 1. So now, f of -x, somebody tell me, somebody other than Asher. Asher told me last time, somebody else. Max. 12x. Correct. So that only changes once. right? So if I do plus minus imaginary, I have 3, 1, 1, 1, 0, and 2. All right? Okay, now P over Q. So for P, we're going to get plus or minus 1, 3, 5, 15. For Q, we're going to get 1, 2, 4. Yeah. Okay, so we're going to do P over Q. And that's going to be plus or minus. All of the P's divided by 1 gives me 1, 3, 5, and 15. All of the P's divided by 2 gives me 1 half, 3 halves, 5 halves, 15 halves. All of the P's divided by 4, 1 over 4, 3 over 4, 5 over 4, 15 over 4. So now what we're going to do, that's a lot of numbers. We're going to do some test points here, right? But before that, give me a minute. All right, so we're trying the 1. Does it work? No. Let's see. So what do we get here? 3, 3. Okay, that doesn't work. Okay, so you know what? We're going to pick another one. So again, up to which one you want to pick. You know what? I'm going to be like a total rebel this time. And I'm just going to close my eyes and pick, oh, that one. 3 over 2. I don't know why. I just seem to like that one. So let's do 3 over 2. Okay. I get 4, negative 12, 25, negative 14, negative 15. Four comes down. Now I need to do 4 times 3 over 2. That's 12 over 2, 6, right? Negative 6 times 3 over 2. How much is that? Negative 9. Then I get how much? 25 minus 9? 14. Times 3 over 2. What do you think? So what I do is, times 3 over 2, I do 14 over 2 first. 7 times 3, 21. Huh? It is 16, I'm sorry. So then it's 24. And then here I get 10 times 3 over 2, 15. Oh my God, like that worked. I would have never guessed that. Oh my gosh, what a lucky guess that was, guys. Okay, so what now? What now? From here, I'm going to get, yeah. So from here, I'm going to get x minus 3 over 2. But in reality, I don't write x minus 3 over 2. Remember how we would write it before? Good job. 2x minus 3. Here I get 4x, 4x cubed.
So the denominator goes in front of it?
Yes. So we started out with x to the 4. When you do synthetic division, it drops by 1. So it's 4x cubed minus 6x squared plus 16x plus 10 equal to 0. Now at this step, you could, okay, so you have a cubic term with 4 terms. You could either do factor by grouping or another one of these. Can you do factor by grouping here? This actually, let's see, this one you can't, because when you factor out an x squared, you're not going to get the same factors. No, if you factor out a 2x squared, you'll get 2x minus 3, but from there you'll get, okay, so let's see. So if we factor out a 2x squared, right, what do we get? 2x minus 3, is that right? What are we going to factor out from here? A 2? Okay, but then we get 8x plus 5. These should be the same. Sorry, guys. I know. It was a good try, but... Huh?
Out of all those, can't we take out a 2? Is that all you can remember?
Still, yeah, you can, but still you're gonna, yeah, right. Okay, now, so that means, you know what we have to do? We have to do synthetic division again. So that means we have to go back to our list and do synthetic division again. Okay? Yes. But now, go to Descartes' rule, right? So look at what Descartes' rule says. This gave us a 0 of 3 over 2, right? Descartes' rule says there is a chance that you have one positive and one negative, right? So there is a chance that you don't have any more positive zeros left. I know for sure that there's got to be a negative 0 in here. Is that right? So the next one, I would try a negative number.
You keep doing it to factor it.
Yes, you keep doing it until you factor it. So let's try a negative number. You know what? Why don't we do negative a half? I'm just feeling lucky today. Why don't we do negative 1/2? Huh? Well, Leah, you got lucky earlier. You just gave us some number and it worked. On the test, it'll be more manageable. Okay? All right. So now, let's do negative 1/2. So if I do negative 1/2, I'm going to put in these numbers here. 4, negative 6, 16, and 10. So 4, oh, sorry. Well, because I want to factor this guy now. I already factored the one above. So 4, negative 2, negative 8. What do we get here? Huh?
In the synthetic division. Because look, there's a 25 in the other.
Negative 1/2 times this, it's positive 4. So 20. So negative 10. Oh my gosh, like, what are the chances? I got lucky twice in a row, guys. What are the chances? Yeah.
Okay, your luck means there is a pattern, and I have to try to figure out the pattern. What is the pattern?
Okay, I will tell you. I'll tell you how I'm doing it. Okay, so look at what we have though. From here, I had the 2x minus 3. This gives me 2x plus 1. Okay? Because not x plus a half. X plus a half doesn't look nice. And then here I get 4x squared minus 8x plus 20. Okay? Now we're going to factor that one. Okay, so what I'm going to do, can I factor out a 2 from here? Can I factor out a 4 from here?
Yeah. You don't do the same problem.
You do the depressed polynomial. I can factor out a 4 from here. But when I factor out a 4 from here, I don't have to write it over here. I could write it at the very beginning of the problem, right? Because everything's being multiplied by each other. So I can put it over there. And I get x squared minus 2x plus 10 plus 5 equal to 0. And so I have 4, 2x minus 3, 2x plus 1. Here, how can I factor that? Can that factor? Oh my God, it does a factor. So now what am I going to do? Not synthetic. What else can I do? A quadratic formula. Look at that. Look at that. This gave us a positive 0 and a negative 0. Descartes told us if you get a positive 0 and a negative 0, the other two are going to be imaginary, so you can't factor that. All right, so let's do synthetic division. So from here we get x equals 3 over 2, x equals negative half, not synthetic, quadratic. X equals negative b plus or minus the square root, b squared minus 4 times a times c all over 2a. Huh? Okay, so it could have been either, right? But, you know, just by looking at it, you know that you have an option of two imaginary, right? Okay, so here x equals...
There's a chance that even though you have a positive and a negative, it's not that.
No, I'll get you in a minute. Let me finish this this one here. So 2 plus or minus negative 16, is that right? Over 2. 2 plus or minus 4i over 2. And what does that equal to? 1 plus or minus 2i. And I already have 3 over 2, negative 1/2. All right, so those are my 4. Now, let me show you a little bit of a shortcut. Let me show you the shortcut I've been using. Okay? So 4x to the 4 minus 12x cubed (25x squared), whoops, 14x. Okay, that's what that looks like, right? So here's what I do. So here's what I do. I do my P over Q. Now it's time to pick numbers for synthetic division, right? And if there are this many, that's crazy. I don't want you guys to be doing this many synthetic division problems. It'll take all day and it's worthless. So I look on the graph. You see where the zeros are. I choose one of the zeros. So for the first one, I chose, luckily, 3 over 2, right? And we did 3 over 2. Okay? No, I looked and I chose. I graphed. I had it graphed here. So I looked and I chose 3 over 2. And then you come across this and you say, oh, I need to do synthetic division again. What number should I choose now? Go back on your graph, choose the second one. Okay? And you go from there. Now listen though. Listen. It's always important for me that you are able to do these without a calculator. So when you have, that many choices, you're allowed to use your calculator. However, do you see how much work is shown here? Just because you use your calculator does not mean that you can leave any part of this work out. In fact, on your test, on a non-calculator section, I can very possibly give you a cute little function for which P over Q is like 3 or 4 numbers, and you have to do the synthetic division manually and figure it out. Does that make sense to you? So you're allowed to use, listen, you're allowed to use the calculator to minimize that tedious work, but not to get rid of the work that you're showing. All right, so this, hang on. This homework, it looks like a lot of problems. Please, please, please read the directions carefully. Some of them only ask you for P over Q, and then you don't have to do anything else. Every single year, a student will come and they'll say, oh my God, I didn't have to solve